the purpose of this project is to identify the regulatory regions across 6 different genomes, fish genomes. Those are among the most important for European aquaculture.
So in AQUA FAANG, what we have been doing is basically trying to exploit functional annotation of the genomes to improve disease resistance, and we are doing it via 2 different ways. First, we are finding major QTLs. We have found a major QTL for BNN resistance in European sea bass, and using the functional annotation of the genome, we've basically narrowed down the mutations that are underlying that QTL to basically find the causative one, which means that without the need for disease challenges, we can directly select our animals to have the resistant version of the genome. But there is another option, that is that through functional annotation, we can, in polygenic traits, prioritize certain variants that are more likely to have function to, one, increase the accuracy of our predictions, and also try to have better predictions between generations, so maybe we can skip some disease challenges.
So the data that's been generated is, in many senses, immortal. It will always be there, it will always be useful. We've collected a lot of very rich metadata describing the samples and the experiments we've done, so it will have a long-term utility to researchers. Everything is publicly available. In the short term, I believe industry will be able to explore the data and look at improving their general understanding of functional genomics in these 6 species. I believe too that the possibility exists to develop functionally enriched SNP panels. So these are developing genomic tools that industry can utilize to improve production traits. Long term, of course, this is the foundation for more extensive exploration into fish genomics and fish biology.
The results are going to be very useful for the future of research and also for the industry in the longer term. One of the biggest contributions to the project is really the resources that have been generated for the different species, the improved reference genomes, the improved annotation of those genomes, the tools and methods that have been developed throughout the project to make it easier for other researchers in the future, whether academic or industry, to work with these species. And I think the applications are going to be, there could be applications when people are ready to implement gene editing, for example, because we know a lot more about where a particular edit could impact on, for example, the regulation of a gene, or it could impact directly on the gene function.
From our point of view, we've shown how easy it is to adapt the genotyping technology that we do to include some of these functional markers. And I think that will be really transformative, just because we can then use all of the information that's coming downstream and that's going to come out of the project in the years ahead.
For the future, we would take information from AQUA FAANG, from the some genome regions that are focused with functional annotation, causal variants, and then we could prioritize the selection of SNPs, and then make low panels, SNP chip panels with low density, but enrichment annotation information, and then provide our customers good breeding precision with less markers and less price.
I think we could say comfortably that all salmon in the aquaculture industry now are being bred using modern genomic tools, or at least close to 90% are. So we hope to be able to refine the panels of markers that we're using based on what we learned from AQUA FAANG. So more functional markers, which will increase the accuracy, even if it's only by a few percent. But for the longer term, we hope that the AQUA FAANG project will help us to understand gene pathways, particularly for very complex diseases like sea lice resistance and other disease traits. And also that it will help us to identify the most important genes, whether it's regulatory or functional, to identify candidate genes for gene editing projects.
In the future, I think we need an even better integration with the industries, so those and have a better uptake of the AQUA FAANG results.
So the AQUA FAANG research infrastructure project will build on the foundation provided by the Horizon 2020 Eurofang projects, including Eurofang, and it offers many opportunities for networking activities, activities around think tanks, for example, for genome editing. Genome editing is a key route to application of the data from the Eurofang projects like AQUA FAANG, and also stakeholder workshops as well. So I think one of the key ways that particularly the AQUA FAANG project will use the data going forwards is by leveraging that data with industry. And there's huge opportunities in the coming years, in the coming decades, as the pressures on global food production increase to use functional annotation in a way that's useful for stakeholders, including industry stakeholders and also consumers, and more widely within the animal production space.
In next level project, I think we also have, I think the diseases is still very important, but I think also we need to look into things that are caused, influenced by the climate change. So warmer water, so things are getting more challenging for the aquaculture. When you get warmer water, then you get more diseases, parasites is a problem. And you start also to shift the production from sea to land-based recirculation production, also with problems with water quality and things like that. So I think facing the future with a different climate is going definitely to be a challenge for us.